Welcome to our channel, our lovely channel, My Udan Classes, where physics meets simplicity. Today, we will dive deeper into the concept of projectile motion, the science behind the perfect cricketing shot, hoop of basketball, or the space exploration. So, stay tuned with this video till the end of this video to master every angle and trajectories. I am Nitesh Sir. I am presenting before you the concept of projectile motion. So let us start the chapter. So see how happily this particular boy is throwing and projecting the object in some angle so that he could be able to just pick up any of the fruit from the tree. So this way we are going to have more and more science exploration, so that once if you are going to get very much expert in this particular topic, so you could also be able to just throw the object like this, and you could be able to just take down all those particular objects which you are in the need to take down. So let us start this topic here and let us go through the part which we are going to cover today. Here we have been already done with the 1D part, means a straight line motion. So in the straight line motion we could have been gone through the topic of uniform motion, uniformly accelerated motion and uniformly non-accelerated motion, right students? So here in this particular topic we are going with the first part, which is introduction of 2D motion. Why so? Because in 1D motion we could have been gone with the simple mathematical equations which could have helped you to solve the equations, which could have helped you to solve the numericals related to 1D motion. So we will be applying all those equations which we have been covered till now in the 1D motion in this particular chapter. So we are going to get introduced first of all with the 2D motion. Then after, the part which we are going to cover is assumption of projectile motion. Then it is the topic of time of flight, maximum height and horizontal range in the ground to ground projectile. And then after are many of the topics which we will be covering in the coming part of the video, which we will be uploading very soon. So today in fact we are going to cover till these 4 points. So here you could have observed that how important is going to be the session today. So please take your notebook, your pen, so that you could be able to pen down all the important topics which we are covering today. So let us start now. Here the first topic is motion in 2D. So what is all about in motion in 2D? So friends, we could have been gone with the velocity, instantaneous velocity, average velocity and all. So we are now going to apply all that in this particular topic. So see what he meant to say. I mean in this particular part, in this particular page, what I mean to say is, if suppose I am telling you that some person has been observed from any of the reference point. This is the reference point from where the person has been observed, and the person is standing somewhere here. So definitely this person is having the coordinate of x coordinate as x and y coordinate as y. Right students? Very good. So we could have been gone with the initial and the introductory part of the 1D motion, or in the vector. We have been seeing the position vector, right? So how you are going to write the position vector here? You can write the position vector like this. R vector is equals to xi cap plus yj cap. If I am not wrong, so you could have been very much familiar with this kind of equation. Yes? So if you are very much familiar with this kind of equation, so why to wait? Let us move ahead with the mode of the part which we have been already done with. Here if I am knowing about the position vector, so is there any problem to find out the velocity? Because we have been already knowing that if we are known with the displacement vector or position vector, the displacement vector with respect to time, if I am doing the differentiation, we could be able to find out the velocity vector. So we are knowing about the position vector, we are differentiating it to find out the velocity vector. So that way we are finding it in this way, Vx I cap plus Vy j cap. Now again if I am going to differentiate it, so we are going to get the acceleration vector, and the acceleration vector will be written in the form of dv vector upon dt vector, which means ax I cap plus ay j cap. So what this equation says? This equation says that here in this particular condition on the x-axis there will be the acceleration which is known as ax, and here on this particular part it will be known as ay. The thing is what? The surprising matter of the fact is what? That whenever this kind of equation come into existence, we get very much shocked. So is this very much tough or what? No, it is not tough. What is the thing? We just need to understand the basic concept. On the x-axis it is ax, students. On the y-axis it is ay. That is the thing. So let us move with the next part, and then let us explore the further part of this chapter. Here I said you, I promised you that I am going to cover first of all the introductory part of the 2D motion. So here it is the 2D motion part. So we all know about the condition which we have been done in the one-dimensional motion. You could have observed that in one-dimensional motion, you could have observed that first equation is what? It is V is equals to U plus AT, right? Second equation is what? It is S is equals to UT plus half AT square. And third equation is what? Third equation is nothing but it is V square is equals to U square plus 2AS. So friends, if I am going to apply all this with the perfect coordinate system, what will be the way we are going to write it? So I am just going to apply the x coordinate in this equation. So if that way I am writing the equation, so how we are going to write? Vx will be equal to ux plus axt. H will become x because we are talking about x-axis. X is equals to uxt plus half axt square. Vx square will be written as ux square plus 2ax, and into x means what? If I am applying the condition of x-axis on these equations, so don't you think that we can apply the same concept for the y-axis? Yes, we can apply, and that's why we can apply on this y-axis system as well. And so we are finding Vy is equals to uy plus ayt, y is equals to uit plus half ayt square, and that way Vy square is equals to uy square plus 2ay sy. It is so simple. There is no any complex thing which need to be very much worried about. So if this much of the part is very much clear to all of you, so why to wait and let us move to the next part. And next part is coming up with one of the numerical. So let us move and start with the numerical part. Here they are saying that the particle starts from origin and moves with constant velocity. Mind it, students, what the question is demanding. It is demanding that the particle starts from origin and moves with constant velocity, and the velocity vector has been given 2i cap plus 3j cap. So if velocity vector has been given, which is 2i cap plus 3j cap, and if I have been given with the condition to find the position after 2 seconds, you don't know that in uniform motion condition what will be the value of acceleration. We know students, what will be the value of acceleration? It will be definitely 0. So if acceleration is going to be 0, so the thing is what? So it is becoming very easier for us now. So if I am going to write down about the displacement vector, so displacement vector will be written in the form of velocity vector and into time definitely. So here the time has been given 2 seconds. So write down the equation of velocity vector. It is 2i cap plus 3j cap, and then you just simply multiply it with 2. Student, what is the thing which you need to just keep in mind is, if I am just going to multiply it, I will find that it is 4i cap plus 6j cap. So this is S vector. So if I am going to write it this way, so what is the thing which we need to know? We need to know that this is going to be the main equation which is in the form of vector. It is in the form of vector. Sorry friends, this is in the form of vector. It is in the form of vector. So if the question will be demanding to find out the moduli, if the question will be demanding to find out the moduli of displacement vector, so what you will be doing? Or otherwise, if they will be asking you to find out the magnitude of the displacement vector, what you will be doing? So is it the thing that both are asking for the same thing? Both are asking to find out the same particular value? Definitely yes, because moduli or the magnitude, both are going to give you the same condition, and that is what we need to find out the magnitude ultimately, right? So we have been already provided with one tool. We have been already done it in the vector part, and if you haven't done, so definitely you must go with the vector part, and you must go with all those equations which you have been covered in your classroom program. So here, if I am knowing about this I cap and j cap part, so if I need to find out the magnitude, so what I will be doing? I am just going to write it in the form of root under a square plus b square, and if I am going to do it in that way, so we are going to get the value of this as 16, 4 square means 16, and this is 6 square means 36. So what it will be? Root under 52, students. It will become root under 52 if I am not wrong. So this is the magnitude of the displacement, and if they are asking you what is the position x comma y after 2 seconds, so this is the x part, this is the y part. If they could have asked you to find out the magnitude, this is the magnitude. What else they can find out? What else they can demand? They cannot demand furthermore. So we need not to worry about these kind of questions. So let us move ahead with the different concept, and let us move ahead with the next part. Here we are going to ask you, we are going to see first of all one of the thing, and that thing is what? That thing is to find out the condition here. They are asking you that acceleration vector has been given as I cap, and initial velocity vector has been given as 2j cap. One second, again just repeat with me what they are saying. Acceleration has been given as I cap, and initial velocity vector has been given as 2j cap. So students, are you observing the one of the thing? Are you observing one of the thing? That thing is what? In initial velocity vector, I cap is missing, and in acceleration vector j cap is missing, students. Means what? Means what? Think once. What is the thing which you have to think? That thing which you need to think is, if you are going to just understand the value of acceleration vector in the j cap, so definitely it will be the null vector, students. Null vector means what is the magnitude? It will be definitely 0. See, what is the significance of 0? Time and time again. So here the thing is what? That here in this case we can say that ay will be equal to 0 and ax is nothing but 1 meter per second square, if I am not wrong. Because I cap says about x axis, so I am writing down the value on the x axis. What is wrong in it? We can write it. Similarly, if I am writing down about the value of u vector, so ux will be equal to 0 definitely. Why? Why? Because x is missing now. If x component is missing, it means what? The value of the initial velocity on the x axis will be 0 definitely. So in this condition, x axis value is 0, and on the y axis it is nothing but 2 meter per second. So student, I have been already given you one hint. I have already given you one hint. and you need to just go through the question paper. You just need to write, see the question, and you will be finding the answer definitely. You just understand they are demanding you what? Determine its velocity after 2 seconds. So who is the student who is reading in the class 11th and they are not knowing about the v is equals to u plus at, s is equals to ut plus half at square, and v square is equals to u square plus 2s? Who is the student? And if he is studying about physics and he is not knowing all these equations, definitely none of any of the students will be such a kind of, absent-minded. If they are knowing about this kind of equation, so we are just going to apply it here. So if you will be applying it here, you can just write down velocity in the x direction will be what? Velocity in the y direction will be what? Can you please let me know what will be the value of velocity on the x-axis and velocity on the y-axis? Please let me know. Yes, please get engaged with the solution part. Be fast. I am here. You just solve it. I am here to just rectify your problems. Yes. So here you are going to observe what? If I am writing about the x-axis, so you just understand the thing. On x-axis, the acceleration part is there definitely. So we will be applying equation of motion on the x-axis. But on the y-axis, acceleration is 0. So why to apply the equation of motion? Why not to go with the constant velocity condition? So जो तेरा हाल है वो मेरा हाल है. What will be the value initially? The same value is going to be the latter part. So in the latter part, whatever the value of velocity initially. So in initial condition, what was the value? Let me know. On x-axis, what was the value initially? Initially, ux was 0. On an x-axis, there is acceleration definitely. And in y-axis, the velocity is 2 meters per second and acceleration is absent. So, what do you understand by this? What do you understand by this? If I am just taking this particular pair, what I am understanding from this? That if acceleration is absent and velocity is this much, so whatever the value of velocity was on 1 second, will be the same value on 2 seconds, 3 seconds, 4 seconds, 5 seconds. Likewise, whatever the second is there, on every second it is going to give you the same value because it is uniform motion. So we are going to write down it here 2j cap. How beautiful it is looking, right? Isn't it? And then if I am going to ask you on the x-axis, so what will be the condition? On x-axis, you just see. That was blue, now I am using green. Yes, this is the pair now. You just think about it. On x-axis, the initial velocity was 0 and acceleration is given as 1 meter per second square. How we are going to find out the velocity? It will be ux plus axt. So if I am writing ux plus axt, students, so what it will give you the value? So ux has been given as 0 plus ax has been given as 1 into time has been given as 2 seconds. So you are going to get the value of it as 2I cap. So if they will be demanding you to find the value of velocity vector, so you can write down the students. So it is going to become 2I cap plus 2j cap. There is no anything to worry. All the questions are very easy for you. Just you need to understand the thing in a different way, different perspective to solve the questions based on the motion in plane, student. Because we have been already covered it in the 1D motion. Isn't it? So here we have been found the value of velocity vector, and so let us give this particular condition a very respectful position. This is the respectful position I am giving you. And then if I am asking to you that please let me know that what will be the position of particle at t is equals to t second, 2 second, and if it starts from origin, so what will be the case? What will be the case? Let me know. What will be the condition? On y-axis acceleration is 0. So definitely sy will be equal to 1 second. If it has been given that acceleration on y-axis is equals to 0. So students, what is the case? It will be the condition that we can say. So we can say that ay is equals to 0. So if ay is equals to 0, so definitely it is the uniform motion. In uniform motion we apply the formula v is equals to displacement upon time. So displacement will be what? Sy will be equal to vy into t. Now let me know what is the value of vy. Vy is 2. Vy is 2 and into t. T is how much? 2 seconds. So you just multiply it, you are going to get 4. And if they are asking you about the y-axis, so it becomes j cap. Are you getting this? Yes. So if I am asking to you about the x-axis, so then what you are going to do? On x-axis, let us take green color. Here it is ax will be equal to, ax is equals to 1 meter per second square. So acceleration is present and velocity is absent. So in that case, what you are going to do? Sx is equals to uxt plus half of axt square. Students, you can do it in this way and you will be finding some value. Whatever the value you are getting, that will be the answer, and that value you need to find out. This is the hint and this is the homework as well. You need to do it by yourself. And if right now you have the pen and paper, you must go with solving this question. So I am not going to just waste more of the time on this question. Let us move ahead with the next question. What for we are taking this much of the question? These are the basic thing which is required to go into the topic of projectile motion. Because these are the topics taken from motion in 2 dimensions, motion in plane. If we will be not knowing about how to just split the displacement in x and y component, velocity in x and y component, how could we be able to solve the complex question of projectile motion? So we are just getting some tools, we are just getting some weapons like sword, and just I am going to apply this sword over here and we are just going to solve the question based on this motion in 2D. We need to just do it in a regular practice, students. If we will be doing it on the regular practice, so we will be finding the answer similarly. Here we are just going to get the condition of next question, and see the case. This particular question is very much similar to what we have covered earlier. The simple thing which is different from the previous question is what? In the previous question, everything was given in the constant form. There was no any variable used in initial velocity vector. Likewise, in the acceleration vector as well, there were no any variable form used in the equations. But right now, in this case, you are finding that the variables has been used. If the variables will be used, then definitely you need to go with the differentiation and integration. And if you are very much understanding, if you are knowing and you are understanding differentiation and integration, so definitely you can solve this question. Differentiation and integration is very much required in this question. Now, where to apply it, sir? Where to apply it? So definitely you must know that acceleration can be found by the help of A is equals to dv by dt. V can be found by the help of dx upon dt. And acceleration can also be written in the form of d2s upon dt square. So these are the things which you must know, before attempting the question of kinematics. 1 second. Yes. How much important it is. See, this is very, very important to understand this concept. Depending upon this, you are going to apply the same concept over here and you will be solving the question. Again, this will be the homework. Solve it by yourself. if you are able to understand and to solve this question, so why to wait, and let us directly switch to Erodov. Directly switch to Erodov. Here, what is the thing? A radius vector of a point A relative to the origin varies with time t as this way. They are giving you the value of r to be 80 I cap minus bt square j cap, where a and b are positive constant and I and j are blah 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 unit vectors and everything. Okay, the equation of the point's trajectory. Yes, trajectory. The thing is what is the trajectory equation and how we are going to understand it. See, in the start of this particular class, I said you that after the end of this topic, we are going to get mastered on two of the thing. One angle and another one is the trajectory. And this is the starting point of the trajectory. So let us concentrate on this question because this is the basic of the trajectory. So you must understand how to find out the equation of trajectory. So to find out the equation of trajectory, the equation of trajectory should always and always obey one condition, and that condition is what? That y must be written as the function of x. And how we can do it, sir? How we can do it? We can do it by a very simple way, very simple method. You know, physics is a very easy subject, and so we are using very easy concept. So here the thing is what? If it is demanding you to find out the equation of trajectory, you first of all write down the equation of x-axis as the function of time, right? You just take out the value of time. You just take out the value of time as a function of x. Yes. And then substitute it. Substitute it at the place of time. In equation of y. This is the simple step you need to take so that you could be able to just solve this question. Now, some naughty minds are there behind the camera and they are just watching this question. So they could be saying, they could be asking me, sir, you are writing it very good, I understand it very good, but please solve the question for us. So I will be saying, yes, I am solving it. You just take the advantage of online class and definitely I am going to solve it. But hereafter, one more question I have been taken and that I am going to give you as homework. See, this is again from my Erodov. I am just going to solve one of the question and one is for you guys. So just see here. So for this particular equation, if they are asking you, then what I am going to do, I can say x is equals to at. It has been given because r vector has been given as, see, r vector has been given as at I cap minus bta square j cap. Student, don't you think that if it is a component of I cap, so this part is the value of x? Don't you think so? Because we know that r vector will always be written in the form of xi cap plus yj cap. We are very sincere student. We all know about all this, isn't it? So at the place of x, what has been given in the question? At. And at the place of y, what has been given? Minus bta square. Oh my God. Depending upon this, don't you think that we can solve the question? Definitely yes. Definitely yes. We are just going to follow this particular method and we will be finding the answer. Definitely I am going to promise you that you will be following this way, this step, and it will be very much helpful for you to find out the equation of trajectory. Just follow it. X has been given in the form of function of t. Has it been given this way? Yes. X is equals to 80. Yes. It has been given in the form of function of time. So what I can do? take out the value of t and write it in the form of function of x. So we are going to write it this way, x upon a. Is there any rocket science behind it? No, not at all. So then if I am finding the value of t, then you just take the value of t and write down the equation of y. Y has been given as minus of bta square. So at the place of t, you just place this particular value of x upon a. I am putting it here, x upon a whole square. So that way it becomes what? Bx square upon a square. So how easy the question of I Irodov? Don't you think it is very easy? I Irodov. Unnecessarily the students who have passed the examination, they have met the height. Unnecessarily. I Irodov is very easy. This I am not saying. You guys, those who are very much talented, they are saying. So I am just penning down all the concepts here. You just write down all the concepts and please hereafter the question if coming out with the same concept, please apply all the same concept there so that you could be able to solve the similar question. Okay, so you just write down all this. Now let us move to the next part. Here the question is demanding furthermore many of the things. The time dependence of the velocity and acceleration w vectors as well as on the moduli of these quantities. So what I will be saying that they have been already given you r vector is equals to ati cap minus bta square j cap. So why to waste time? Directly can't we find out the value of velocity vector? Yes sir. How we can find dr vector upon dt sir? So directly you can differentiate the equation of position vector and you can write down here. So if I am writing down, so what I will be finding? If I am going to differentiate this will become ai cap minus this will become 2tb j cap students. And if I will be asking to you to find out the value of acceleration vector, and if you are the smart students, and definitely you are the smart. So what you are going to do? I have been already taken a number of questions with this concept. You are just applying, right? Here I have been already said you that if the position vector will be given, find the value of velocity vector by differentiating with respect to time. Similarly, if I am asking you to find out the value of acceleration vector, you just do one thing. You just differentiate this equation with respect to time once again, and you will be finding the value of acceleration vector. So easy. So here you are just going to pen down this concept and you are just going to differentiate it. So that way we will be finding that this becomes 2bj cap. It becomes 2bj cap. So student, we have been already taken out all the values, and if they will be asking you to find out the moduli of velocity vector, so if they will be asking you to find out the moduli of velocity vector, so moduli means what? We are going to find out the magnitude, root under a square plus b square you can do, and that way you can find out the value of the magnitude or the moduli of the physical quantity which is vector in nature. Are you getting my point? So these are the concepts you must keep in mind. See. Next question is about the time dependence of the angle alpha between the vectors omega and velocity. Alright. So if they are asking you to find out the dependence of the angle alpha between the So if they are asking you to find out the dependence of alpha, so what we can do? Can't we just take down the condition of alpha? Alpha is the angle between the acceleration and velocity. Suppose two of the physical quantities has been given. Two of the physical quantities are vector in nature, and if we have to find out the value of alpha, what we are going to do then? We are just going to do one thing, and that thing is what? We are going to do, if this is, suppose in this particular I-Erodo, many of the times they used to consider acceleration as W vector. Okay. So if they are considering acceleration as w vector and the velocity vector has been given, if I am asking to you to find out the theta between them, what we are going to do, we can apply dot product concept. Apply the dot product concept. So that way we can write down velocity vector, sorry, acceleration vector dot velocity vector can give you omega magnitude, velocity magnitude, cos theta, and if that way we can write down cos theta. So cos theta will be written in the form of omega dot velocity vector upon omega v. So this is the key point. We can say crux. This is the crux of the given condition the question is demanding. So if we are going to do the dot product and just dividing it with the product of the magnitude, so definitely we will be able to relate it with the angle. And once we are going to relate it with the angle, that is the thing which was demanded by the question. So easy. So we have been already done with this one, and the mean velocity vector average. So let me know one thing. Again, if they are asking to you to find out the mean value of any of the function, if someone is asking you to find out the mean value of any of the function, and the function has been given in this way, it has been given in this way, it is function of time. So what we are going to do, if we have to find out the average value, so we can do, to find out the average value, we can write down this as this symbol, and we will be finding it by doing the integration. It will be written as y dt and upon dt, and the dt will be done in between the I mean to say the limit of 0 to t time period. Here again it will be done within the limit of 0 to t time period. These are the key points which you need to keep in your mind, because these are the mathematical tools which you must know. This is the mathematical tool, students. By this mathematical tool, we can find out the mean value. Now, someone from you may ask, sir, can you please give some example? I will be saying yes. Yes. I am giving you one example. Y has been given as 4t squared. I am telling you to find out the average value of y within the limit of t is equals to 0 to t is equals to 2 seconds. So in that case, what we are going to do? We are just going to integrate it. 4t square will be integrated with the derivative of dt within the limit of 0 to 2 seconds, and then after it will be divided with the dt within the limit of 0 to 2 seconds, and that way we are going to get the average value of y. So friends, what it will become? 4 into t cube by 3 within the limit of 0 to 2 divided by t within the limit of 0 to 2. So see, 4 into 8 minus 0 by 3 divided by 2 minus 0. So whatever the answer you are going to find out, that will be considered as the average value of this function. Similarly, this way you are going to find out the average value in the question which has been given here in the IE Irodo. So Jai Ho Irodo Baba Ki, and depending upon this gesture, I am moving ahead with the next question, and the next question is what? Again IE Irodo. Again this is a gift from my side. This will be considered as the homework. You just need to do it by yourself. Let us now move ahead and let us now talk about projectile motion. Yes, this was the moment I was waiting for. Here, now I am talking about projectile motion. So what this projectile motion is all about? If some object will be projected, this way, if the object will be projected this way by making some angle theta from the ground, so this object, this velocity can be splitted in the component. u cos theta, u sin theta. And similarly, what happens that in this case, this particular motion will take place under the influence of acceleration due to gravity. One more time, this motion takes place under the influence of motion under gravity. So definitely motion under gravity takes place in which direction? Motion under gravity takes place in downward direction. So that way it is the value of minus g. This is the value of minus g. So if this is minus g, so acceleration has been given to you. So depending upon that condition, you can say that the velocity, if it is in the upward direction, if the velocity is in the upward direction like this, so these two of the vectors are making 180 degree within each other. So what will happen? That one of the vectors will oppose another vector. Means what? This is the acceleration, this is the velocity, and due to acceleration or velocity, either the object gains the velocity, gains the speed, or it loses the speed. It will gain the speed when both will be making 0 degree with each other, and it will lose the speed when the angle between two of the vectors will be 180 degree. So here you are just seeing, you are watching it here, that the angle between two vectors are 180 degree. So that way, what will happen, that every second the value of velocity will be getting decreased by the factor of 10, because the value of g is 10 meter per second square almost. So every second the value of velocity will be decreasing by the factor of 10. Means what? The value of velocity has been given as 40 meter per second. So if it has been taken from t is equals to 0 and the value of it is 40 meter per second, then at t is equals to 1 second, it will be decreased by the factor of 10. So it will become 30 meter per second. How much it will become? 30 meter per second. So the value is decreasing by the factor of 10 every second. Yes. So depending upon this concept, if I am applying it here, we will be finding that if u sin theta was the initial velocity in the y direction and it was being opposed by acceleration due to gravity, then in some particular condition or at some particular moment, you will be finding that this value of u sin theta becomes 0, and that condition is here. That condition has been given with the concept with the name of maximum height. And this is the horizontal range. Horizontal range is what? Horizontal range is the distance covered by the projectile motion on x-axis. So what happens? The motion has been taking place in the x-axis as well as on the y-axis. It is not that way. Y-axis it is covering height, and on the x-axis it is covering horizontal range. On y-axis it is covering height, and on the x-axis it is covering horizontal range. So that is the thing. So this must be in your mind, so that you could be very much familiar with the nomenclature, with the terms and terminology which we are going to use in the projectile motion. Here, all these things which we are going to see means if any footballer is kicking the football at some angle theta, so it is covering some displacement. If I am going to find out the displacement will be covered from the initial point to the final point, and if it is going to be connected with the straight line, it will give you the displacement. So this will be written as displacement. Alright friends, so these were the terms and terminologies which are going to be used in projectile motion. Now let us move ahead. Assumptions. What are the assumptions? So see husband, particle remains close to Earth's surface, so acceleration due to gravity remains constant, air resistance is neglected. One thing, that acceleration due to gravity varies with altitude. Altitude means height. You have been already covered it in class 9th in fact. It will be varying with the depth as well. It will be varying due to the rotation as well. Earth is rotating? Say yes or no? Yes, definitely yes. And if Earth is rotating, so there must be the condition that acceleration due to gravity should vary? No. No. Why? Because it is under the influence of it is under the influence of very constant velocity, and that velocity of Earth doesn't affect the value of acceleration due to gravity. And the altitude must not be that much higher that the acceleration due to gravity starts behaving like a variable condition. And the depth must not be that much deeper that the same condition arises of acceleration due to gravity, that it is behaving like a variable condition. So in that way we can say these three conditions must be taken care of so that the acceleration due to gravity must behave constant. Again, air resistance is neglected. Why neglected, students? If acceleration due to gravity is present and air resistance is present, so definitely it will result into some resultant value, because both are same nature of vector quantity. So it will result into some resultant value, and if that is the resultant value, so in that case what will happen? That the acceleration will be getting changed. Distance that projectile travels is small, so that Earth can be treated as plane surface. All it has been covered in these 3 points. Now let us move to the next topic, next point. Method to analysis projectile motion. See, here on this side it is u sin theta. Why? Because this is the initial velocity, and the initial velocity is projected with some angle theta. So if you are going to split it on the x-axis, you will be finding the value of initial velocity to be u cos theta. On the y-axis, you will be finding the value of it to be u sin theta. So that way we are getting the value of it on the y-axis as u sin theta. At some certain point, the value of velocity on the y-axis becomes 0. That will give you the maximum height. H max. Similarly, on the x-axis, the acceleration is 0, and if you could have been remembering the points which we have covered in the motion in plane part, you must know that acceleration is 0, it means it is uniform motion. So on the x-axis it is uniform motion. So students, what is the case? Here it will give you the maximum height, and there you are going to find out the uniform motion. So combining these two concepts, we are going to get into the next slide. So just leave it. Here we are finding the different cases of projectile motion. What are the different cases? This is called as ground to ground projectile. This is said to be ground to ground projectile. Why? It is because from where the object has been projected, it is coming on the same horizontal level, so it will be said as ground to ground projectile motion. Here, if the object has been projected horizontally, it is coming to some particular point on the ground, and that point is h height below the point of projection. So in this case, we can say projectile from tower. Projectile from tower. And this is called as projectile motion on an inclined plane. These are the 3 cases which we are going to cover mainly in this topic. So here now we are coming up with the next point, The next point is what? How to observe velocity in x and y direction. Students, we have been already done with the part of motion in plane, and in motion in plane I already narrated one point that if suppose some of the axis is having zero acceleration, consider the motion to be uniform motion on that axis. And if if either of the axis will be showing the constant acceleration, so in that axis you consider uniformly accelerated motion and apply the equation of motion accordingly. So this is the part which we are now seeing. This is one condition when any of the object will be projected with some velocity and the initial velocity has been considered to be u. See, this is u, which is the initial velocity, and it has been projected with some angle theta. If suppose this object, this velocity is u and it has been projected with some angle theta, so the x component of this velocity will be considered as u cos theta. This is 100% true, and similarly on the y-axis the component will be said as u sin theta. I hope you also agree with what I am saying. So depending upon that, if I am saying that projectile motion happens under the influence of acceleration due to gravity, and acceleration due to gravity takes place on y-axis. Yes, student. So if it is taking place on the y-axis, so this is the y-axis part and this is the x-axis part. You just bifurcate all the physical quantities of both the axes separately. So that way I am writing down it here that ux is u cos theta, ax is equals to 0, x is equals to displacement in x, and vx is equals to u cos alpha. Why u cos alpha? That I will be saying you, but in fact this u cos alpha and u cos theta will remain same. Why? Because ax is equals to 0, so the motion is uniform motion in that case. This is uniform motion. I am just discussing right now on the point of ground to ground projectile motion. Similarly, if I am talking about uy part, means the component or all the physical quantities on y-axis, we will find that it is under the influence of motion under gravity. So, motion under gravity is what kind of acceleration? This acceleration is uniformly accelerated motion. So definitely we can say that it is nothing but uniformly accelerated motion. We can say it is uniformly accelerated motion. Now the student, the question is, if it is uniformly accelerated motion, so which of the equation we can apply to solve the numericals for y-axis part and similarly for the x-axis part? So definitely if I am the student and if I am going to apply the concept, I will definitely solve the mathematics for both the axes separately. So let us dive into the concept of this part and let us explore more of the part of this both the x and y axis. Let us move to the next part. Here it is. The question is, a particle is projected with a speed u at an angle theta with the horizontal. Find the average velocity of projectile for the period during which it crosses half of the maximum height. See students, what it means to say. It is saying what? That if suppose this is y-axis and this is x-axis, and it can be said that if you just suppose that the object has been projected with some angle theta, it is saying it has been projected with a speed u, it has been projected with some speed u and at an angle theta with the horizontal. Find the average velocity of projectile for the period during which it crosses half of maximum height. So see, this way it is going. This is the projectile motion which has been taking place. Now what I am saying, that at half of the maximum height, suppose Suppose this is the maximum height which has been taken here. So what will be the half of the projectile motion? Definitely half of it will be this one. I hope you all are getting my point. So what I can say that if suppose at the initial point, the initial velocity was u sin theta in this way, and it was on the x-axis u cos theta this way. So this is u cos theta, and this side it is u sin theta. So student, if I am asking to you that this is u sin theta and this is u cos theta, let me know one thing, that we have to find out the average velocity. Alright. So on the x-axis, do you think that any of such point comes where the velocity is changing? On the x-axis it has been given, right, that acceleration on the x-axis is 0. If acceleration on x-axis is 0, it means what? The motion is uniform. It is uniform motion. So if the motion is uniform, it means what? जो पहले का हाल है वही बाद का हाल है. Means what? Whatever the velocity is initially, whatever the initial velocity is there, it is u cos theta. Same is the value as Vx. So definitely if I am telling you that what will be the average velocity, so it will not be changed, because average velocity is what? U plus V by 2. Ux, later also it is ux divided by 2, so it becomes ux. So ux average is nothing but ux. I hope you understand my point. Clear? Now if I am talking about the condition of y-axis, on y-axis, what happens? On y-axis, here you just let me know that suppose I am telling you what, you just see. If I am telling you that at this point some velocity is Vy. So at the same height, the same velocity will be there, but in the downward direction. Why so? Because it is taking place under the influence of acceleration due to gravity. And in the topic of acceleration due to gravity, you could have observed that it follows the symmetry. Symmetry means what? Whatever the value of velocity will be on this side of the motion, at the same height, the same velocity will be there on the another side of the motion. So that way what happens? Whatever the value of velocity was on this side, if I am saying that this is Vy, so the same velocity will be there on this side. Alright, very good. So we can say that average value of velocity in y direction will be what? It will be u plus v by 2. What was u? It was Vy. So let us suppose it is Vy. And later it is minus, so it becomes minus Vy by 2. So it becomes what? 0. Very good. So the average value of velocity, if you are going to write down, what you will be writing? Average value of velocity, you can say it will be velocity in x direction ka average I cap plus velocity in y direction average j cap. In x axis it is ux, so it becomes ux I cap, and on y axis it is 0. So definitely it is 0. So the ultimate answer is ux I cap, which will be considered as V average. V average. So please give the respect to this answer, and we are going to give the respect now. This is the respect to this answer. Suppose if I am telling you that on the same height, how you are going to find out? So you are going to follow this way. But if suppose if I am asking to you for this height, I am asking to you that what is the average value of velocity between this point and this point, this point and this point. So in that case, you need to find out the value of velocity here. You need to find out the value of velocity here, and you just need to apply it on this formula. You will be getting the value of average value of velocity. Let me explain it with another example. See here. What I am saying. I am saying that if suppose this is the projectile motion. This is the projectile motion. I am telling what? That if suppose the object has been projected with some value of velocity, and the value of velocity is some angle theta with the ground. This is u. So in that case, what we can say? Projectile is taking place this way. So if I am asking to you that if this is the projectile motion which is taking place, so let me know one thing. Let me know one thing. Can't I ask you one question? That what is the value of average velocity between initial point? This is the initial point, and let us suppose final point is coming at this point somewhere. So if I am finding the average value of velocity in between these 2 points, so this 2 point is lying between these two conditions. Are you getting my point? Yes. So what I can say, that if suppose I need to find out the value of velocity here, the value of velocity will be what? Suppose this was 0 second, this was 0 second, 1, 2, and at the top point it takes 3 seconds, and this is the part I am talking about the time which is 4 seconds. If I am considering this is an example. I am just considering the example of t is equal to 4 seconds. So what will be the value of velocity? It will be nothing but Vy is equals to Uy plus Ayt. Time has been given, Uy you know, Ay you know, minus G. You can find out the value of velocity very easily. Yes. So in that way, if I am asking you to find out the value of average velocity in y direction, average value of velocity in y direction, so in that case, what I can say? I can say Uy plus Vy by 2 Vy. We have found this way. Uy you already know. You just need to write down it here, and you will be getting some answer. So what I am saying, that if we have found the average value of velocity at the 2 points at same horizontal level, so definitely by using the same formula we can find out the average velocity in between either of the points lying in between the region of projectile motion. Are you getting my point, students? Yes. So let us move with the next part of the chapter, and we are now moving for the concept where we are going to find out the time of flight. What is time of flight? So students, we are talking about the time at which when the object will be projected from the initial point and it comes to the same horizontal level, that time is called as time of flight. So what I am going to narrate it here, it is the time taken by object, it is the time taken by object at which the object comes back to the same horizontal level in projectile motion. What are the key points in this definition? The key point is nothing but, these are the key points. It is the time taken by the object at which the object comes back. At which the object comes back to the same horizontal level. This is the point. Comes back to the same horizontal level, and this we are talking about the case which comes under projectile motion. projectile motion. So if we are finding time of flight, so what we need to do? What I am saying, it is coming at the same horizontal level. So at the same horizontal level, what is the key point? Displacement will definitely be 0. Displacement in the y direction will definitely be 0, and so we can say that we can apply Sy is equals to 0 in this case, and we know that in y direction, acceleration in the y direction is nothing but minus g, which is constant in nature, means it is under the influence of uniformly accelerated motion on y axis. So we can apply the uniformly accelerated motion on the y axis, and we can find out the time by keeping the value of displacement in y direction to be 0. So we are applying it here this way. Sy will be equal to uyt plus half of ayt square. If suppose I am putting the value of displacement in y to be 0 and uy is something like uy only, which is u sin theta t, and here it becomes minus of half of gt square. If you are just going to take it on this way, so we can say half gt square is equals to uyt. So this t cancels out the power this side, and time you are going to get as 2uy upon g. Again give the respect to it. So this is about the time of flight. This is about the time of flight. So we can just say that time of flight is a very important part. Time of flight is a very important part. We need to take care of this much of the part so that we could be getting the idea that what exactly the time of flight is. Are you getting my point? Are you getting my point? So this way we just need to concentrate to find out the time of flight. This is a definition you take care of. Coming to the next point, it is nothing but maximum height. What is the maximum height, student? So all the time from the starting of this lecture, I am telling all the time and again, I am telling you what I am telling you, that the motion is under the influence of acceleration due to gravity on y-axis, and on x-axis the acceleration is 0. So motion is uniform motion. So what I mean to say is that at the maximum height the value of final velocity will become 0. If the value of final velocity becomes 0, we can say final value of velocity is 0. We need to find out the value of height to be what, and acceleration on y-axis we all know that it is minus g. So I think that it is very clear to all of you that which equation is valid here. Which equation is valid here? To find out the height, we can say we can apply v square is equals to u square plus 2as. If you are applying it in this way, you just give the respect y respect, sir. Here vy is 0. uy square plus 2ay sy means it becomes minus 2ay sy. So what will be the value of sy? Sy is nothing but uy square upon 2ay, and this is nothing but displacement in y direction when the final velocity in y direction is 0. And when this happens, what this displacement is called as? This displacement is called as the maximum height. See student, we have been already discussed here. We have already discussed it here. See, this is the maximum height, and at the maximum height uy will be considered as 0. So this is the point which I am discussing it right now. Here at this point I am telling you the same thing. So here what happens? So if I am applying this concept, I am going to get the idea that h will become uy square upon 2ay. If I am putting the value, it becomes u square sin square theta upon 2g. AG, OG, log, small g. Write down all this. This is the key point now. This is about the maximum height. If you are at all in the mood to find out the maximum height, you can just go with all these concepts to find out the value of maximum height in ground to ground projectile motion. Student, now comes horizontal range. Horizontal range means what? Means what? If you could have observed that particular slide, you could have been knowing about this idea that what the horizontal range is called. The horizontal range is the distance from the initial point to the final point on the x-axis. On the x-axis. So we must take care of all the physical quantities which are existing on the x-axis. Which are existing on the x-axis. So that way we can say on x-axis, acceleration is 0. We know that the velocity is u cos theta. Very good. And similarly, if I have to find out the displacement in x direction, so if the acceleration is 0, sir, motion is uniform, sir. If the motion is uniform, sir, which formula we can apply, sir? It is nothing but v is equals to displacement by time. So if I am very sincere student, I can say v into time. So v is how much? It is u cos theta. It is u cos theta, and time is how much? The total time of flight. And what was the value of total time of flight? It was nothing but u cos theta into 2u sin theta by g. Student, we can say that u cos theta is ux? Can we say it is ux? Can we say it is uy? Yes, definitely. Yes. So either you remember this formula in this way, u square sin 2 theta by g. Either you remember the formula in this way, or you may remember the formula of horizontal range to be 2 into ux uy by g. Whatever the formula suits you, strikes your mind easily, you just go with that formula. I am in the mood to say just one thing, and that thing is what? That is the condition that you just need to keep the formulae, all the formulae which we have been derived now in your mind, so that we could be able to go up with the next slides and questions which are coming in your way. Here, next point is what? What are the angle at which the range is going to be same? What are the angle at which the range is going to be same? So the answer is what? It will be complementary angle. Complementary angle means what? Complementary angle means what? It is theta 1 plus theta 2 must become 90 degree. It means what? If suppose that theta 1 is 30 degree, then we need to just put the value of theta 1 to be 30 degree, and that way we can find out theta 2 will be 60 degree. After adding these two angles, if the value of these two angles comes out to be 90 degree, this angle is said to be complementary degree, and at these two angles, the range is going to be same. Is this clear? Very much, very good. Can I give you one question? Yes, sir. If I am telling you theta 1 is theta plus 45, and I am telling you theta 2 is nothing but theta minus 45, do you think that this will result out to be, at this two of the angle you can say that the range is going to be same? Do you think so? So what we will have to do? We are just going to apply theta 1 plus theta 2. If I am applying it here, we can find it out that it will be getting cancelled out. Means theta plus 45 plus theta minus 45. See, this and this is going to get cancelled. It becomes 2 theta. No sir, it is not valid. So I am asking you another question now. I am just reversing the order. I am saying it is 45 plus theta. and theta 2 is 45 minus theta. Do you think that at these two angles the range is going to be same? Let me know. So again what I will do, I am just going to add it up. Theta 1 plus theta 2. If I am going to add it up, I am going to find it out that 45 plus theta plus 45 minus theta will result into the value of 90 degree, and so in that way we can say as the result is 90 degree, so this is complementary angle, and so at these two angles the range will be same. But in this case it was not. Is this clear? So what I am going to say you is what? That you just add up all those equations, all those angles, so that you could be finding out that whether those two angles is forming the complementary angle or not. If it is forming, then the range in both the angles is going to be same. That is what I mean to say. Clear? Clear. Very good. So depending upon all this, now we are going to attempt several questions, and depending upon the several questions we are going to get the idea. So friend, what I have to say is, these were the theory behind the projectile motion. Today I am going to end of the class till now, and so we are going to come up with the next part of this chapter in the coming slide. I mean in the next video. And the next video I am going to record it tomorrow. I hope today's session was very interesting for you, and by this particular topic of projectile motion I found very much engaging with you guys, and it was very interesting to teach you all. By the same hope and by the same condition, I am just telling you bye, and this bye is just till next video comes. So thank you for being patient on our channel My Udan Classes, and if you found the topic to be very interesting, please hit like, share and subscribe, and that way just keep us motivating to come up with more and more such a kind of interesting videos in the near future. Thank you very much.